to stimulate throwing a pie in someone's face, but instead use whipped cream in a container. And you can see this through the diagram. So what we did was we found the distance, which was about 2.60 meters, and we found the average change in time, and we took 3 trials and divided by 3 to find an average time of 1.35 seconds. The acceleration was 9.8 meters per second squared. The mass was 0.636 kilograms, and this is the same approximate mass of a small pie, and the initial velocity was 0 meters per second. So what we're trying to find is the final velocity, the work, the change in potential energy, and the change in kinetic energy.
So first we're going to find the change in potential energy before the pie is released. So to find that, you need the mass and the acceleration due to gravity and the change of the vertical distance. So after you plug in all your information that we got before, you get 16.2 joules. And just to make sure that this is right, we did a check to find the work. The work is the force multiplied by the displacement multiplied by the cos of theta. So when you plug in all your information, the force is the weight, so mass times acceleration, and cos 0 is 1. And eventually we get the same answer, 16.2 joules.
Okay, so in our last calculation, we found the work and the potential energy. So using that, we used the work energy theorem to find VF. So work total equals the change in kinetic energy, and the change in kinetic energy is kinetic energy final minus kinetic energy initial, but Ki is going to be 0 because Vi is 0, so that can just be cancelled out there. And when we input everything into our equation, we come out with a VF of 7.14 meters per second. Now to check our answer, we also went to kinematics. So for VF for that, we ended up with 13.2 meters per second. The discrepancy between these two is because of air resistance. In our kinematic formula, we have T, and it came out with a larger T because it spent more time in the air than it would have if there was no air resistance. So that's the difference between the two. Okay, so another fun little calculation that we did is we wanted to see how high up you would have to be to make the final velocity the same as the average pitcher velocity of a baseball. And the average pitcher velocity was 42.5 meters per second. So we input that into a kinematic formula using some of the variables that we already had, and we came out with the distance of 92.0 meters.